Section 1.2 Mathematical Models. A catalog of essential functions. A mathematical model is a mathematical description, often by means of a function or an equation of a real-world phenomenon, such as the size of a population, the demand for a product, the speed of a falling object, the concentration of a product in a chemical reaction, the life expectancy of a person at birth, or the cost of emission reductions. The purpose of the model is to understand the phenomenon and perhaps to make predictions about future behavior. In Figure 1 down here, it illustrates the process of mathematical modeling. Given a real-world problem, our first task is to formulate a mathematical model by identifying and naming the independent and dependent variables and making assumptions that simplify the phenomenon enough to make it mathematically tractable. We use our knowledge by the physical situation and our mathematical skills to obtain equations that relate the variables. In situations where there is no physical law to guide us, we may need to collect data either from the library or the internet or by conducting our own experiments, and examine the data in the form of a table in order to discern patterns. From this numerical representation of a function, we may wish to obtain a graphical representation by plotting the data. The graph must even suggest a suitable algebraic formula in some cases. You start with a real-world problem, formulate to create a mathematical model. Once you have a mathematical model, you solve to create a mathematical conclusions. Once you have your mathematical conclusions, you can interpret and then make real-world predictions. And then test, and then you start back at the beginning again. Now, the second stage is to apply the mathematics that we know, such as the calculus that will be developed throughout this book, to the mathematical model that we have formulated in order to derive mathematical conclusions. Then in the third stage, we take those mathematical conclusions and interpret them as information about the original real-world phenomenon by way of offering explanations or making predictions. The final step is to test our predictions by checking against new real data. If the predictions don't compare well with reality, we need to refine our model or to formulate a new model and start the cycle again. A mathematical model is never a completely accurate representation of a physical situation. It is an idealization. A good model simplifies reality enough to permit mathematical calculations, but is accurate enough to provide valuable conclusions. It is important to realize the limitations of the model. In the end, Mother Nature has the final say. There are many different types of functions that can be used to model relationships observed in the world. In what follows, we discuss the behavior and graphs of these functions and give examples of situations appropriately modeled by such functions.